Well, I was told that this was going to be a keynote talk, and then I was told there were going to be 3 keynote talks. And I wondered what it would be like if you went to the opera or something and they had 3 instruments giving the keynote. I mean, I suppose you'd have Wolfgang Walster, he'd be the oboe, right? You know, right absolutely on the note. And then, you know, I was thinking I would come at the end, but I'm coming at the beginning. I suppose I'm sort of the first time you've ever had the bagpipes giving the keynote at a concert. I want to just give one slant on the way I think our field has been going wrong and how I think it might go right, which is not to say that I don't think that there are lots of other slants that could be taken on it. It's about translation as far as I'm concerned. Translation is the part of language technology that I've devoted most of my life to, and that I maybe have a little bit more to say about than anything else. And I want to distinguish it from what is sometimes called transcoding. That's a word that I got from Canada, where they have a way of trying to find words that will work both in French and English so that they can be a bilingual society but still only use one word for lots of things. And it's basically transcoding is replacement of a word or a phrase by another word or phrase, and then maybe reordering things a little bit. Okay, and it's a very useful kind of thing to do if you want to be able to read web pages, or if you're the CIA and you want to track terrorists. These days, for funding purposes, we have decided to call transcoding a word you may not be familiar with. We call it translation. It's not what translators think of as being translation at all, but it sells much better under the term translation than it does under the word transcoding. Translation is the production of texts that are equivalent to one another, but for the language that they happen to be in. At least that's the ideal. Handy for dissemination of science and technology, for maintenance and repair manuals, for news reporting, for intelligence gathering, which is different from simply tracking terrorists, for international agreements, legal contracts, and so forth and so on. There is much greater need in the world today for translation than there is for transcoding, but we have allowed the people who do transcoding to take over the word translation from us, thus doing us all a great deal of damage. So that's sort of the thing that is under my skin that annoys me and may put just a little bit of an edge on my voice. Transcoding is replacing words and phrases by words and phrases that mean the same thing. In a rather technical sense of meaning, that's the sense of meaning that linguists use. There isn't an everyday sense of meaning that you can really tie down. Translation is preserving the meaning, but what is the meaning? Well, the meaning is whatever gets preserved under translation. I mean, it's a completely circular definition, so it's not, the everyday use of the word meaning is not very much use to us. Let's call this semantic processing. It is processing languages according to the meanings of the words and phrases in them. Almost everybody would imagine at first that that is what translation is quintessentially about. It's about semantic processing. It's the sort of thing that really does occur when people do translation in the course of learning some foreign language. What happens is that the teacher gives you things to translate, as it's called, and what you're supposed to do is to demonstrate that you have learnt the stuff in this most recent lesson. That you have gone home, you have taken the list of words in the end of the chapter, and you have learnt them all, and you can use them in simple sentences. It's also, and partly as a result of that, the popular perception of what translation consists of. It's absolutely always has been what machine translation is all about. Find out what the words mean. Occasionally you have to override what the words mean by what the phrase that the word occurs in means, then reorganize that a little bit, and the result is called a translation. Translation, as I would like to use the term, is the replacement of words and phrases so that they affect equivalent changes in the mind of a reader. That, I put to you, is a different kind of enterprise, and I will call this pragmatic processing as opposed to semantic processing. This is what people go to translators school for. I don't know whether you've ever wondered why they have translators schools and why people spend money to go to them. There are lots of bilingual people around. Why don't we just use them and do away with the translator schools? Would that not be more efficient? And the answer is they go there because there is something to be learnt there. Transcoding and translation are two entirely different things, which is not to say that they don't overlap in some ways. Most things overlap in some ways. But if we decide to take the transcoding route, if we decide that that's what we are going to do, we should do so in full realization that the translation route is orthogonal to it in many ways. If you are working on translation and you are doing well, and you are making progress, and your blur scores are increasing, it does not mean that you are making any substantial progress on translation, as I think of it, and as I think many people think of it. So work on one contributes little, some, but little, to work on the other. 20th century language processing failed because it could not connect with the outside world. There was no artificial intelligence in it, still less any natural intelligence in it, and therefore, since it did not make contact with the real world, it was unable to deal with the real world problems that are absolutely all over any attempt to use it. 21st century language processing is failing because it does not even care about the outside world. So it's what they do for the most part. What has been noticed, it was noticed years ago, that if you put words together at random in accordance with the statistics you get from triples or quadruples or something, there's a certain sort of local sense that it seems to make, except that you can't quite get your arms around it. There's a certain sort of familiarity that the words seem to have with one another, but somehow the thing as a whole doesn't make any sense. There's a game called Consequences that works this way. You write things on a piece of paper and then you fold the piece of paper over so that the next person to write something can only see what the last person wrote and not the bit before. And so you get something like this, which has a certain sort of local coherence, but apart from that has little to recommend it. This is the achievement, much vaunted achievement of modern day machine translation. This is what we have learnt yet again to do. Another form of it is called dissociated press. It's done on a computer this time, but it puts together things in a local statistical manner, and people are impressed because there is no particular point at which the moving finger going through this can stop and say, this doesn't work. It works just here and one word on either side, but it doesn't work much beyond that. In the translation, maybe the main verb will get left out. Maybe the word not will get left out or put in. But the local coherence, that's what we care about, and that's what will stay together. Let me give you an example. I always give examples in any talk I give, so here's my example for today. It happens to me every week as I go back and forth to Saarbrücken. As you get off the train, somebody says, and I think I got these words right, though they come through a loudspeaker and I may not have got the details quite right. Versichern Sie sich, dass Sie nicht in dem Zug vergessen haben. Okay? And this comes across in French as rassurez-vous que vous n'avez rien oublié dans le train. Okay, and this is wonderful transcoding. It's good translation, and it works out as translation does one sentence in 3, but not more than that. It works out as transcoding. Versichern Sie, rassurez, sich, vous, das, que, and so on, like that. Absolutely beautiful. Well, you know, occasionally you have to split things up, don't you? And of course you have to reorder a little bit. But it's pretty much word for word. There we go. Now, in English, you could do exactly the same thing. You can do transcoding of English and say something like, make sure that you have forgotten nothing on the train. And I could put little red boxes around them, and I could animate it and make them move, and we could transcode both of those two things into English. Of course, if you look at it pragmatically, somebody might say, make sure you've forgotten nothing on the train. Well, I forgot to call you on the train. Or I forgot my password on the train. There are lots of things that you can forget on the train, but somehow they don't have to do anything to do with this forgetting that somehow the person on the loudspeaker seems to be talking about. Maybe it could have been transcoded as make sure that you have left nothing as opposed to forgotten. I think I said left before. Forgotten nothing on the train, and I could say, well, I left the trash on the train. There was no point in bringing it on. Or I left the stuff on the car at home, but I left nothing on the train. I have all that with me. This is famous preposition attachment stuff. In fact, the companies, the railroad companies, didn't use either of those two translations at all. They decided for their own purposes to say, make sure that you take all your belongings with you. Now, in the popular sense of meaning, this means the same thing. In the linguist, in the semanticists, in the philosopher's notion of meaning, these are very, very far from meaning the same thing. You might reply, well, I couldn't take all my belongings with me. I didn't have all my belongings with me in the first place. I left your briefcase on the train, but none of my belongings. What we know is going on here, the reason why we can understand this pragmatically is that we know that this fits into a little scenario, a little skit, a little play that we all know about leaving things on trains and about there being lost and found offices or lost property offices or numbers that you can call. And we know about, even the sign has gloves and umbrellas in it. These are the things that you leave on trains. You don't leave other people's briefcases. The first approach to this was a semantic approach. The one that was made in English, I'm claiming, was a pragmatic approach. And learning to do pragmatic translation will teach us lots and lots of other things that we really badly need to know about translation, and it will take the efforts of all of us to do it. Look at situated language as it really occurs. This occurs on a gate close to where I live in Paris, but also in lots of other places. Look what this sentence consists of. A picture of a dog hiding behind a red cross, beneath which there is an adverbial phrase, even when not on a leash. And you are supposed somehow to understand from that dogs are allowed on this side of that gate, but not on the other side of the gate, not even if you are holding them on a leash. You cannot put that together out of those signs and those words with no further help. You have to put that in a pragmatic context. If you happen to know French and English, then I invite you to translate this one into English. I have given this to students for years and have never got a good translation for it. It means, in a word-for-word sense, I can't even think of the English for piéton. What's the English word? Pedestrians. Attention. Cross in 2 times. Or in 2 steps. No, the road's too wide for 2 steps. In 2 stages, something like that. It turns out you have to see the road in order to figure out what this means. If you don't know what that bit of the word looks like, you aren't going to be able to translate this into any language. 20th century language processing failed because it could not connect to the outside world, because we did not know what to tell the machine about the outside world. We sat down and we tried to actually write out in rules for KRL or whatever your favorite knowledge representation language is about. We tried to describe the world to the machine. Not surprisingly, looked as though it was going to take rather a long time, and people didn't invest too much energy in it, because even if you did manage to describe the whole world to the machine, it might not be quite the kind of description the machine needed, at least not by the time you got to the end of it. We didn't know what to tell the machine, and we didn't know how to tell the machine about the world. We didn't know what the machine needed to know, and even if we had, we wouldn't have known how to sell it. Now, these days we depend a lot, as I've said before, I keep coming back to this, don't I? We have these language models that we trust for so many things. Now, remember when you next build a language model, that languages, their words, their phrases, their rules are famously subject to Zipf's law. You've all seen the shape of Zipf's law. So that almost everything you learn about a corpus is not about a language, but about the world. The first few words, the first few hundred words you look at tell you a lot about the language. To learn that much again, you probably have to look at 1,000 words. And to learn that much again, you probably have to look at 10,000 words or whatever it is. The dilution of linguistically interesting material is tremendous, grows tremendously over time, but you are learning. The wonderful thing about Zipf's law is it's entirely to our advantage as human beings. It works wonderfully for us because it means that we have the information we need to learn the language fast. It comes quickly and at the beginning. But we can continue learning thereafter. Having learnt the linguistic stuff, we steadily build up knowledge of the other things that the language is telling us. So the language model, after a very short time, is not telling us anything much worth knowing about the language at all. It's teaching us about what the language is being used to talk about. So not surprisingly, when you take these systems and you move them to a slightly different domain, they don't work anymore. So our current best model of the world consists of n-grams. And Google has the world's best model of world knowledge because it uses 7 grams. That is our view of the world. That is what artificial intelligence has been replaced by. Shall we consider getting serious for a minute? What machine translation desperately needs is to know what everybody knows, our common knowledge, what everybody in our society at the very least knows about the world. But we do not know what that is. So we need, whoever thought you would hear me say this, we need machine learning, but not to learn 7 grams, but to learn what it is to live in this world, what the world is like, what the facts are about the world, how it works, how it is that when you cross a road, you stand a chance of being run over. Simple things like that, that every person knows and that are behind some translation somewhere sooner or later. So we need machine learning that would enable robots to learn how to deal with the world and talk to us about that experience. So language translation needs more than knowledge of words, phrases, and even, I didn't mean the word, I meant the world, but I left an L in the hotel. We need robots and not encyclopedias, because robots, because they have to live in the world, have not only to know what the world is about, but they see things as we see them in context. That's to say, they see every little piece of language as situated in some particular context. It is in some sense embodied language, everything they see as related to them. And we must understand that if we want to use this technology in order to do the kinds of things with language that humans do. So the problem that faces us, if I am right, is to bring up a generation of robots, training them to translate, and that may take us a while. And we are in a hurry. We need to get things done much faster this year than last year, and much, much faster this decade than last decade. So the robot is going to have to think the way humans think, remember, because he's going to be second-guessing humans. There's an old story, it goes back, I don't know to whom, that says, look, we need the machines to do these jobs, but they don't have to do them the way human beings do them. And at some low level of detail, that may be true. But there's a very, very important sense that these robots must do what they do about the world and must understand the world the way human beings do, because that's what they're there for. They're there to read a text that humans have written and to react to it the way a human being would. There is no other purpose that they serve in this scenario. So maybe what we need is a lot of little robots. Maybe they can get together and talk to one another about what they've found out today about the world. Maybe they will develop different slants on the world or different specialties. Maybe this is robotic crowdsourcing. I don't know what particular catchword will be associated with it. So let me give you some class projects and then I'll stop. My seminars always have projects associated with them. So these projects are going to be of the form, build a robot that can learn how to do something or other, and then translate a description of how to do it. So, old-fashioned thing, everybody's ever tried to build a robot, you try to make it figure out how to find the way to the cafeteria without bumping into too many things on the way. Well, have it find the way to the cafeteria, and then have it come back and engage in a conversation with me, in which I can say things like, oh, do you mean the corridor outside John's offices, or the way at the end of the building? And you'd say, oh, of course, I should have said the one at the end of the building, and so forth, that I can have a conversation like that based on partially shared knowledge. if somebody in the group doesn't happen to be into language processing, most people in the group had better be into language processing, but if some of them happen to be into other things like making omelets, then you could have the robot make an omelet, and there's a lot of discussion about how to make an omelet. I learned recently that you don't actually stir it with a fork the way I used to, but you sort of, there's a wonderful little shake of the wrist that you can get that does wonderful things when making an omelet. Have it find out and then explain to me something which nobody else has ever been able to explain to me, so this is perhaps a particularly difficult one, namely how to use the German words doch, schon, and wohl. Or even just how to add up a column of numbers, or to debug a circuit. Not, notice, how to ride a bicycle. Why not? Lots of people can ride a bicycle. Why not teach the robot how to ride a bicycle? Because despite the fact that everybody in this room can ride a bicycle, there isn't a single person in this room, I'll bet, who knows how to do it. You simply can't tell me how to ride a bicycle. You can get on a bicycle and ride it, and I can watch you, and I can hope to learn that way, and that won't get me very far either. So a conversation about riding a bicycle, well, yes, it might be interesting, but it won't teach me to ride a bicycle, and playing the violin is even worse. You need a good violin teacher if you want to play the violin well, not because the violin teacher will tell you how to play the violin. They will tell you that, no, don't do it that way, try something else. And they will keep saying that until what you try works a lot better than what you tried before. But they won't be able to tell you how to do it. And that's as far as it goes.
So Martin, thank you very much for your talk. And now that finishes the more structured part. We have the introduction, we have the keynote, and now we have short presentations. We should have time for discussion. And maybe we keep to look in each other's eyes. Maybe this is a good time for discussion if there is something anybody wants to say in this moment. If this is the case, just give it a little hint. All right.
Martin, this is Gudrun Magnusdottir, in case you don't know me. Martin, you suggested robots. Now we are in a world where we can be thinking of experience-driven avatars. Could we think in that way instead? To collect knowledge from a virtual world rather than our own? Or is that too artificial?
Well, I tend to the view that the less artificial it is, then the better. After all, the people whose language we want to have learned, not somebody else in some other world. So it had better be a world that we can control very well.
But it's working. Just very.
Yeah. What if learning a language is in this lot of riding a bicycle and playing a violin?
The microphone is your friend. Just give it a try.
I think it is in large measure like that, and that is why I do not believe you can tell it how to do it. I believe on most of these things we have somehow, on the one hand, to tell it how to do it, but not to imagine that telling it how to do it consists in counting trigrams or something.
So,
very close.
Yeah. So the best way for a robot to really learn what we know and what enables us to use the language right and thus to translate if we happen to know more than one language, is actually growing up in a family, right, with parents. So if you go a little further, wouldn't we have to say that that many things the robot will never detect unless having grown up and in a family and gone through school and so on. So that's more provocation now to ask this way. But the second part would be, so if it's really true that we need to go so far, and if we know on the other hand that anthropomorphic robotics is still very, I mean, you talked about also other types of robots that can learn. They don't have to look like people, yeah? But if that is so hard to solve even easy problems in robotics, could you imagine, Martin, another way of importing at least large parts of this knowledge, of this world knowledge, before we have the right type of robots?
I think I could imagine ways of importing it if there's some source that can export it to me. But I don't know where it's going to come from. I think that you can do a lot of bootstrapping. You do not have to have had all the experiences of everything in the world that you can understand. You can understand some of it by virtue of other things. That is why 19th century novels are so good at getting to understand human nature. I mean, you don't have to have met all the kinds of crazy people there are in the world. You can read about half of them.
Hello, thank you. I'm Peter Herby from Heidelberg. What Martin suggested was exactly 40 years ago what Vinograd with his schedule started to achieve. And so my question is, what happened? Why don't we, his system of this robot who played in a real world and acted, and you could define even words. You had the whole pragmatic in it. It personally influenced me to get into this discipline. And now, if we look at the future, what happened? It is 40 years ago that the first of us tried to talk to have a robot who could work in a toy world, who could talk with a human. So it should be interesting with what we would have more success, and what were the reasons why was this line of research not so successful as we thought in those times.
Martin, you answer? So what happened? I mean, it seems we didn't use 40 years.
There was no original thesis work. We tried to tell the machine what we thought it ought to know, and we didn't pull it off.
Okay, so moving 40 years forward again to our times, and maybe even envisioning the next 40 years, then we see that larger parts of the world get modeled for completely different reasons. Yeah? They get modeled, give you some examples. So an airport gets modeled in order to construct and organize it better with all the procedures. Yeah? Before they build it, they are building right now a new airport close to Berlin, and they have a huge three-dimensional model, and then they learn how to improve this model by sending people, they call them actors, comparison, sending thousands of people through and testing the airport before it will be opened, yeah? And then they improve the model. And right now Google tries to model our cities, yeah, by Street View and getting three-dimensional models. And we are trying to model more and more processes, yeah, to finer detail. So I'm asking now about whether there could be, in case we don't get the robots fast enough, yeah, to help us, whether we could squeeze out of these models of real world, of procedures, processes, yeah, if we could get out of these things that are, usually they don't have a high level, yeah, they're modeled on a much lower level, but then machine learning partially works on lower level input data, yeah, whether this could already help us.
I think it possibly could, but I think the key to this sort of thing is having models that are integrated from the start and in a crucial and central way with the linguistic system. I think the two things have to grow in parallel with one another. And we may luck out. Somebody's model of an airport or somebody's model of this or that may have the components that we need to develop a parallel linguistic component, but then they may not.
Thank you. Felix Sasaki, University of Applied Science, Potsdam. So you made a very good comparison to human translators, focusing on the aspect that they learn something at translation schools, like the pragmatics aspect of translation. So if I think of translators, we are translators of manuals for users of a washing machine. We're translators of manuals how to build a washing machine. There might be manuals of how to transport washing machines. It's better now? So what I'm aiming at, for all these, so this is now just one machine where you want to explain things and 3 manuals which might need to be translated. Would you have to build 3 robots which learn all these things? And you could go to other areas, using parking an airplane on the airport, building an airplane, and so on. So for all these very similar situations, you would need very different kinds of robots. So for similar contexts, you would have, well, basically very different ways of translating things by humans. So would you then also need different robots learning the translation?
I think you're onto a very important point there, but it's a different point than I was making. This is the point about knowledge of a domain. So we talk a lot, and always have done, in language processing and in artificial intelligence about knowing the domain. I'm much more interested in knowing the kinds of things that everybody knows in order to structure an argument, in order to know the kinds of distinctions that one can and cannot make. The people who translate washing machine manuals usually don't make washing machines. They're usually professional translators, and they don't even know the fundamental terminology that washing machine makers use. But they do know a lot about the way people interact about things in the world. You see, it would be really nice if I could tie this down with really key examples to show you how it works and doesn't work. But in order to do that, I would have had to solve the problem. Which, of course, I'm going to do, but...
Thierry.
Yeah, it seems to me that you were talking about reconciliating the knowledge of the world and the knowledge of the language. And I was thinking that nowadays, compared to the 20th century, we have at least a lot of semantic resources in the form of taxonomies, ontologies, where you have a lot of linguistic expression associated to them. And we work currently on this and to say, okay, in this case, you use the linguistic expression associated with a concept or with a term, with a label and ontologies, and then you don't translate, but you just use what is being described in another knowledge system, in another language. Do you see a way there to improve the kind of translation like the one you mentioned in the train?
Moment.
Anything we can get, we should grab and try to use, that's for sure. Yeah. Ontologies may be an important thing, a very important component to humans' linguistic linguistic abilities and the way they the way they tie the language to the rest of the world? I don't know. I hope so. Maybe that would be, that would be nice if they were. I don't know. I've never built the robot to find out.